this chemist may have cracked America's rare earth problem. One flash is all it takes. That's how James Tour believes America can tackle China's rare earth dominance. All he needs is discarded electronics, of which the United States has mountains. And from these scraps, the Rice University chemist and nanotechnologist has pioneered a way to quickly extract rare earth metals. We can pull out one metal and then the next, he told the Epoch Times. It's really that simple. Tour's solution is flash joule heating, rapidly heating up the materials to thousands of degrees to vaporize the metals. Mixed with chlorine gas, the vapors turn into chlorides that emerge at different temperatures. Just like in an incandescent light bulb, the technique works by passing an electric current through the raw material, Tour said. But whereas the former channels a steady electric current to create a perpetual glow, in treating metals, the energy arrives in short bursts, dialing up heat in milliseconds. Metals are infinitely recyclable, so you can recycle it again, he said. And whereas the traditional way of distilling metals is rather messy, Tour said, what he proposes is all about simplicity. You flash and you're done. Speed is now more critical than ever. The United States is racing against time to reshore rare earth production, spurred in part by China's October threat to dramatically curtail access. With a one-year truce in hand, Washington now has a short window to close the gap. Getting a mine up and running can take 15 years. Tour says his technology would put the United States on a faster track. It would give us a map to get independent, he said. His invention is modular, he said. You can get these things going for a few tens of millions of dollars. That's not very much when it comes to this type of manufacturing. U.S. dominance lost to China. Rare earths, a subgroup of 17 critical minerals, serve as essential components in electric vehicles, wind turbines, smartphones, and missiles. China currently sits at the center of this vital global production chain. It makes more than 90% of the world's rare earth magnets, according to International Energy Agency data. China is also the sole supplier for certain elements such as samarium, used in fighter jets and nuclear reactors for its high heat resistance. This dominance comes from decades of strategic investment, lavish state subsidies, and aggressive market manipulation that stifled foreign competition. Decisions made in the United States also played a part. Until 1991, the country was a leading rare earth producer, with the Mountain Pass mine in California supplying most of the world. Environmental troubles then shuttered the mine for years at the same time China began to gain a foothold. Against the Pentagon's objections, the U.S. government greenlit the 1995 sale of Magnequench, then the industry leader in rare earth magnets, to a Chinese front group, effectively handing over critical defense technology and manufacturing to China. In 2004, Magnequench closed its Indiana plant and moved operations to China. Beijing started taxing rare earth exports the following year. Fast forward 20 years, the United States is now beholden to Chinese minerals. We didn't realize that we were selling something that turned out to be very important to our country, Tour said. Waste to treasure. As early as 1976, the United States had a law regulating electronic waste disposal. In the years that followed, the ballooning electronic waste created a whole recycling industry that still struggles to catch up. It's now the fastest growing type of waste, rising 5 times faster than recycling, according to the United Nations. The United States produced 7.2 million tons of electronic waste in 2022, about 1/8 of the world's total, the latest UN data show. That's about 46 pounds for every American. We have these mountains of tailings that we can access, and we have these constant mountains of printed circuit boards, Tour said. Tour said that their method could clean up the spiraling nightmare of waste sites and turn it into a treasure. This is a win-win all around. Lucas Eddy, Technology Development Manager for Metallium's Texas subsidiary Flash Metals USA, is now seeing the idea being put into practice. The real reason a waste product isn't because it's bad, it's because it can't be used, he told the Epoch Times. Here's where flash joule heating shines, said Eddie, whose Texas factory has licensed the method for metal recovery. This is the future of flash joule heating. Old tech reimagined. Joule heating, passing an electric current through a conductor to produce heat, has been around since the 1840s. It's now an integral feature of every household, in toasters, electric heaters, ovens, and hair dryers. Until now, no one had thought to use it for electronic waste. The spark for Tor's team began with reading a scientific paper describing using flash joule heating technique to make metallic nanoparticles. Taking that as an inspiration, the researchers tested it on carbon and found it a quick way to make high-quality graphene at low cost. They next began exploring its potential in extracting the much-needed rare earth metals. Eddie, a 2025 Tor Lab graduate, joined the project in early 2021 just as this shift began. It's really live chemistry in action, he said. You see a rainbow of colors coming off. Each change of color represents one metal element that has separated out. Rare earths, usually with some of the highest boiling points, tend to come out last, often as a white powder, he said. The project drew interest from the Defense Advanced Research Projects Agency, which asked them to make it more industrially applicable, Tor said. Under a federal contract, the team worked on lowering boiling points, experimenting with fluorides and chlorine in various forms, and eventually settled on chlorine gas. That step was revolutionary, said Eddie. Until now, electronic recycling has largely relied on submerging electronic components in strong acids, an approach that creates large amounts of toxic chemicals. An alternative is to heat up materials in furnaces, an energy-intensive process that requires high upfront investment and additional purification. Converting metals to chlorides bypasses that intermediate step. The ultra-fast heating and cooling rate also cuts down energy use by as much as 87%, according to a Tor co-authored paper, published in Proceedings of the National Academy of Sciences in late September. It's much cleaner and much faster, said Tor. Every scientist's dream. The technique has wide environmental applications beyond rare earth metals. The researchers have used it to remove toxic metals from red mud, the byproduct of aluminum production, leaving an aluminum-rich material that can go into ceramic tiles or back into the regular aluminum production cycle. Jewelry manufacturers have approached them for the gold in the electronics, and others sought the purified glass on cell phones after they extract lithium, Tor said. Even the plastic parts on the print circuit boards can be useful, he said. Under high heat, he said, plastics break down into carbon monoxide and hydrogen, a fuel source and cornerstone in chemical manufacturing. There's very little waste in the process, Tor said. It's a big win for our country. It's a big win for the environment, and hopefully it's going to be a big win for the investors. They are still optimizing the temperature control system to increase metal purity. But for what they have, there's already a market. In September, the Pentagon awarded Metallium a Phase 1 contract to distill the critical mineral gallium from waste streams. The company's commercial-scale plant outside of Houston is on track to start production in early 2026. Tor said the goal is to process 1 ton per day of print circuit boards by January, and 20 tons by September. 2 additional sites in Massachusetts and Virginia are now in the works. According to Tor, when he pitched the idea to a group of NATO generals, one of them stood up and said this is going to prevent wars. Most wars are fought over resources, water, oil, minerals, Tor said. People fight over this, and they kill each other over this. From Asia to Australia to Saudi Arabia, President Donald Trump has been building a coalition around the globe to counter China's critical minerals chokehold. Tor said he's excited to see his innovation developing into potential national security leverage. To be able to solve a critical problem for the country, this is like every scientist's dream. With reporting by Jan Jikilek.